Another day, another story. Welcome to this video where we'll explore the fascinating world of large language models, LLMs. These models are at the forefront of natural language processing and understanding, and in this video, we'll dive deep into what makes them tick and how they're used in various applications. A large language model, or LLM, is a remarkable artificial intelligence model known for its enormous size. These models owe their expansive scale to AI accelerators, which can process vast amounts of text data, often scraped from the internet. LLMs are built as artificial neural networks and can contain a staggering 1 billion to even a trillion weights. Their training relies on self-supervised and semi-supervised learning techniques, with the transformer architecture playing a crucial role in speeding up this training process. LLMs function by taking an input text and predicting the next token or word in a sequence. Until 2020, fine-tuning was the primary method for adapting these models to specific tasks. However, more massive models like GPT-3 have introduced the concept of prompt engineering, allowing them to achieve similar results without extensive fine-tuning. These models acquire knowledge about language syntax, semantics, and even the inherent biases present in the data they're trained on. Some notable examples of LLMs include OpenAI's GPT models, such as GPT 3.5 and GPT-4, which are famously used in ChatGPT. Google's PaLM, Meta's Llama, and other models like Bloom, Ernie 3.0 Titan, and Anthropic's CLAUDE 2 are also noteworthy contributors to this field. One critical aspect of LLMs is probabilistic tokenization. This process involves transforming text into a sequence of tokens, which are the basic units the model works with. LLMs use a modified byte pair encoding algorithm to tokenize text efficiently, resulting in a fixed vocabulary size. However, this approach may not work optimally for languages other than English, as it can split words into suboptimal tokens. The quality of the training data is paramount for LLMs. Dataset cleaning involves removing toxic content, discarding low-quality data, and deduplicating entries. As of 2022, cleaned datasets used for LLMs can contain up to a staggering 17 trillion words, a significant increase from earlier models like GPT-1 and BERT. Reinforcement learning from human feedback, RLHF, is a critical step in fine-tuning LLMs. Algorithms like proximal policy optimization are used to further improve model performance based on human preferences and feedback. LLMs have made strides in instruction tuning, allowing them to generate more accurate responses. They can replace naive responses with correct ones based on human-generated corrections, leading to improved performance in tasks that require specific instructions. Prompt engineering has become a game-changer for LLMs, enabling them to achieve results that were previously only possible through costly fine-tuning. However, this technique is limited to the scope of a single conversation or context window. The attention mechanism is a crucial component of LLMs. It calculates soft weights for each token within the context window, allowing the model to focus on relevant information. The number of attention heads and the context window size can vary among different models, impacting their performance. The size of the context window dictates how much of the conversation a model can consider when generating responses. If a conversation exceeds this window's size, the model must either truncate it or use summarization techniques. Adjusting the context window size is a delicate balance between computational cost and maintaining context. LLMs can be trained in two primary ways: autoregressive, where the model predicts the next segment in a sequence, or masked, where it fills in missing parts of a segment. These models may also undergo training on auxiliary tasks to test their understanding of data distribution. In conclusion, large language models have revolutionized the field of natural language processing. Their immense size, training techniques, and applications in various domains make them a powerful force in AI. As these models continue to evolve, they will undoubtedly shape the future of human-computer interaction and language understanding. Thank you for joining us on this journey through the world of large language models. Thanks for watching.